everyone, this is Miss Blanton and I'm going to be working your 9497 review. As you all should know, your review is due on the day of the test, and your test is on Tuesday or Wednesday, depending on if you're A day or B day. As you know, it is a 100 quiz grade if you attempt every single problem. Alright, let's get started. Number 1, circle all of the polynomials that are in factored form. That would be B, that's a factor, that's a factor. D is a factor, and F. B, D, and F are all in factored form. Number 2 says, from number 1 above, you need to factor all of the polynomials that are not in factored form. And if they are already in factored form, just simply rewrite them. Starting with A, x squared plus 5x plus 6. Well, we're going to be factoring. So we open up our factor brackets. The first terms need to multiply to get x squared. So I know that will be x and x. And then the number that goes in each factor, they need to multiply to make 6, but then also add to be 5. So we need to think about the factors of 6. We have positive 1 and positive 6. 1 times 6 is 6. But the problem here is 1 plus 6 is 7. And we need 5. So 1 and 6 are not going to work. How about 2 and 3? 2 times 3 equals 6. And 2 plus 3 equals 5. So this is going to be x plus 2 and x plus 3. B, we decided was already in factored form, so we'll write it as it is. Okay, C, x squared minus 16. If you remember anything from section 9.7, you'll know that that is a difference of squares. Something squared minus something squared. That's x squared, and 16 is 4 squared. Using our formula, we know that the factors will be, since we have something squared minus something squared, it'll be x plus 4 and x minus 4. Okay, we'll see some more of that later. Part D. That one was already in factored form. E. 4x squared plus 20x plus 25. Now, hopefully your first instinct is to go, oh wow, I wonder if there is a GCF. Well, we have 4, 20, and 25. There's no GCF here. This one has an x squared, this one has x, this one doesn't have a variable. So we can't factor out a GCF. Now we need to see if maybe it's a special product. Well, we know it's not difference of squares. We've got 3 things being added together. Much different than something squared minus something squared. Perhaps it could be a perfect square trinomial. We know if it's a perfect square trinomial if the first term is something squared and the last term is something squared, and the middle is a combination of the two. When you write it like this, it's very obvious that 4x squared is something squared, because 2x squared is 4x squared. And 25 can be written as 5 squared. So according to our formula that says if you have something that's in this form, then the factors are just a plus b quantity squared. So we need to have something squared, we'll call it a, something squared, we call it b, and in the middle it's supposed to be 2 times the a times b. So 2 times 2x times 5. Is that 20x? 2 times 2x would be 4x. 4x times 5. That is 20x. So that means we can write our factors in this form. 2x was our A, and our B is 5. It goes to this one. Okay, we'll see some more of those later too. F was already in factored form. So we write it how it is. On to number 3. Our directions are solve the equation. And we have 4 different equations. These are already in factored form. This is something we saw in section 9.4. Already in factored form, they ask us to solve the equation. So we're going to set each factor equal to 0 and then solve for the variable. So I took this factor, set it equal to 0, and then took this factor and set it equal to 0. Starting with this one, c plus 5 equals 0. Well, since we're solving for c, we're going to move the 5 to the other side, letting us know that c equals a negative 5. On to this one, c minus 4 equals 0. We need to get c by itself, so we send the 4 to the other side, which changes its sign. So we have c equals negative 5 and c equals 4. This is what it looks like to solve the equation. Variable equals number. Variable equals number. Okay? On to B. Same thing. We're going to take each factor and set them equal to 0. Start here. 2k minus 1 equals 0. We need to get the k term by itself, so we send the 1 to the other side. K is still not by itself, so we divide by 2 to get that k equals 1/2. Okay? K plus 2 equals 0. We send the 2 to the other side, sign changes, k equals negative 2. And we're done. C. We're going to set each factor equal to 0 again. Now solve for x. If x minus 3 equals 0, then x must be a positive 3. If x plus 4 equals 0, then x must be negative 4. On to D. Set each factor equal to 0. We need to get the b term by itself, so we send the positive 7 to the other side, making it a negative 7. Still need to get b by itself, so we divide by 3. And you can leave your answer as a fraction. Okay, same thing over here. We're going to send that negative 7 to the other side, which is going to make it a positive 7. Trying to get b by itself, so we divide by 3. And that's 4. GCF stands for greatest common factor. Okay? So we're going to find the greatest common factor of these 3 terms. There's no coefficient in the front, but I always recommend you should start with the coefficient. Since these don't have coefficients, we'll move on to the variables. Let's look at the a's first. This one has a to the 3rd power, a to the 7th power, and then the third one has a to the 3rd power. So the most a's they have in common would be 3. So you'd put a to the 3rd power. Let's look at the next variable. This one has 4 b's, this one has 5 b's, and this one has 2 b's. So the most that they can have in common is 2 b's. This one has a c value, this one has a c, but this one doesn't have a c. So a c term is not going to be part of their greatest common factor. And we're finished. Number 6. We have this term, and this term. Like I said, I recommend you start with the coefficient. We have 2, 8, and 14. Typically, it's good to check and see if the lowest number you have happens to be a factor of the other numbers. So we'll check and see if 2. Is 2 a factor of 8? Is 2 a factor of 14? Yes and yes. So part of their GCF is going to be the number 2, because 2 doesn't have any larger factors. Now let's look at the variables. We have an x. This one has 3 x's. This one has 7 x's. This one only has 1 x. So the most x's they can have in common is 1. Okay, let's look at the next variable. We have 3 y's. Oh, this one doesn't even have a y. So, no y's in the GCF. And we're done. Number 7. Now that you are a GCF master ninja, you are going to factor out the GCF of these polynomials. So we'll start on polynomial number 1. First thing they ask us is just for the GCF. So we have 16x to the 7th power minus 6x to the 3rd power. Remember, start with the coefficients, that number in front. 16 and 6. What is the biggest factor that they have in common? Well, the factors of 6 are 1, 2, 3, and 6. 6 is not a factor of 16. 3 is not a factor of 16, but 2 is. So 2 is the coefficient of our GCF. Now let's look at the variables. We have x to the 7th power and x cubed. So the most x's that they have in common is 3. And that's our GCF. Now to factor out the GCF, we're going to factor out 2x cubed from this polynomial. So when we divide 16x to the 7th by 2x cubed, that's going to give us 16 divided by 2 is 8. X to the 7th over x cubed is just x to the 4th. So that's what's going to go here. For negative 6x cubed, when we divide that term by 2x cubed, divide the coefficients first, that gives you negative 6 divided by 2 would be negative 3. And we have an x cubed on top and an x cubed on bottom, so they will cancel each other out. So negative 3 is what's left over. 2x cubed times 8x to the 4th minus 3.